Hi kids, it's time for some math. We've been learning about perimeter for the past week or so, and we have thought about finding perimeter or the boundary around by measuring with a ruler and adding up the lengths. We've also thought about it when we didn't need to measure because the length was given in a picture. So this is another way we thought about perimeter, by adding up the side lengths. And so that was another way we saw it. But today we're going to think about perimeter when we're building it with unit blocks. And you don't have these, but that's okay because you can just watch me do it once with the blocks and then we'll do it together on paper. So today, just a quick preview of what you'll be doing. Instead of having a drawing or a ruler where we measure, we are going to imagine building a shape with unit blocks. And for me, I could have set these all up like this so that you could see them, but I decided I don't need to do that. Like a unit, you can see that these represent units. So I have a perimeter on this side or a length on this side, 1, 2, 3, 4, and 5, and 4, and 5. So the perimeter of my rectangle is 4 plus 4, which is 8, and 5 is 10. So the perimeter is 18. But what you also can see, because of what we've learned this year, you are maybe making the connection that, oh yeah, this is also an array. We have an array of 4 groups of 5. So an array is what we used. I'll just jot this down. This word array, this is what we used early in the year to find the area. It's the space covered. So we had 4 groups of 5. And so if I were looking for area, I wasn't, but my array could help me find area. And I hope you're seeing the connection between these words, array, area. They're pretty similar, aren't they? So 4 groups of 5. 1, 2, 3, 4, 5. Did I do too many that time? No. 4 groups of 5 helps me see the area or the space covered by my units. Now in our lessons these past few days, we haven't been finding area. We've been measuring the perimeter, the distance around. So in today's lesson, we're going to kind of explore how those two are related. And the way I'm going to teach it to you is by working through a page that I did not assign to you. But if you want to, you can go look at it. I want to use the application problem as my main way of teaching the lesson, and then I'll complete some of the problems with you from your Learn book. So this is Lesson 18, page 91. It says that Rita says that since 15 is larger than 12, she can draw more arrays to show 15 than she can to draw or to show 12. Is she right? Model to solve. Well, Rita is thinking about arrays, and so she has a total of 15, and then she also has a total of 12. Well, let's see. I think the way I'm going to think of this is to kind of split my paper in half. More arrays to show 15. Well, if we want to make an array, we need to think of multiplication facts. We can list all the pairs of factors that make 15 when you multiply them. And boys and girls, it's maybe been a while since you did this, but we can start with 1. So the factor 1 times 15, that's going to be one of our arrays. What is another way to make 15? What makes 15 when you multiply it? Does 2 times anything equal 15? No. But 3 does. 3 groups of 5 equal 15. And then 5 groups of 3 will equal 15, won't it? So that's the commutative property, the flip-flop it back and forth property. 6, 7, 8, 9, 10. Nothing else is going to make 15. So we were supposed to draw and model. So one group of 15. So here's my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have one group of 15. There's my first array, and then, so I could check that off. I'm done with that one. And then this one is 3 groups of 5. Okay, 1, 2, 3, 2, 3, 4. Doesn't have to be perfect. So that should be 5, 10, 15. So I have 3 groups of 5. Both of these arrays equal 15. Now down here we had 12. So her theory was that since 15 is bigger, there would be more arrays. Well, let's think. What factors make a product of 12? Well, we have 1. We always start with 1 and then we keep going. So let's take our factors. One group of 12 equals 12. Keep counting up. 2 groups of 6 equal 12. If you know your math facts, this is not hard. Hey, I can even do 3 groups of 4 to get 12. Well, already I can see that even though 12 is less, we can draw more arrays. So let's just start building these out. So one group of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One group of 12. 2 groups of 6. 1, 2, 3, 4, 5, 6. Here's my 2 groups of 6 and 3 groups of 4. There they are. 1, 2, 3 groups of 4. Okay, well, are there any other ways to make 12? Well, the 4 times 3, that's just the reverse of this one. 5 times nothing, 6 times 2. So nope, this is it. So to answer the question, we would have to say, good thinking, right, Rita, but you're not right this time. So no, Rita is incorrect. We can draw more arrays to show 12 than 15. And we could spell that all out. So now this is where I want to teach you the new stuff. Because really those are things we learned way back in October. I want to try something a little bit different right now. If we were to take these arrays, and boys and girls, this is not what this page is asking for. This is something that I want to do to show you what's coming up in this lesson. If we were to take all of these arrays and instead of thinking about the area, if we were to look for their perimeter, if we were to pretend that these were units, I'll just take this one here. Whoop. If we were to pretend that these were units, I shouldn't have made that so long. Instead of just dots in an array, you know, maybe if we were to pretend like it was units like these, okay, instead of dots in an array. What is the perimeter of the shape I have here? And I'm admitting to you that this is poorly drawn. I should have gone like this, okay? What is the perimeter of my shape? Well, let's see. I have 1 length here, 12, 1 length here, and 12 down here. So the perimeter of this array would be 1 plus the distance around plus 12 plus 1 plus 12. So perimeter is the distance around. I'll just take one more color just to make sure you see it. Perimeter is not when we count like the array, it's when we count the distance around. We measure the distance around. So the perimeter of my shape is 13 plus 13, which equals 26. So this is really something worth thinking about. The area was 12. The perimeter was 26 units. Huh. Let's take one of these other pictures. I kind of scribbled on that one, so I guess I'll use this one right here. Let's pretend that instead of just a plain old array, we have this drawn out like unit squares. What is the perimeter of my shape? Well, this side is worth 2, and this side is worth 6. So the perimeter is 2 plus 6 plus 2 plus 6. So the perimeter equals 8 plus 8 is 16. The perimeter around 2 plus 6 plus 2 plus 6, perimeter is 16. Now, did the area change? Nope. It's still 12. The area is 12 no matter how you reconfigure it, no matter how you visualize it. The area didn't change. It's still 12 units. But the perimeter changes, doesn't it? Look at that. When we did a 2 by 6 array, yeah, it's still 12, but the perimeter was 16 units. When we did a 1 by 12 array, the perimeter was 26 units. So this big idea, kids, that the area can be the same and the perimeter can change is something we're going to explore a lot this week. Now I'm going to do some of the problems with you. On page 93, you have a chance to, you're not going to use unit squares. I don't have papers for you, and we're not going to use these. We're going to use pencils and grid paper, and we're going to build as many rectangles as you can with an area of 24. Then we're going to shade in the squares on grid paper to represent each rectangle that you made with an area of 24 square units. Okay, so they did something here where you could start it, but I'm going to jump to page 97 because your book actually planned ahead and gave you a piece of grid paper. So they said 24 square units. We're going to do number 1 here on this paper on page 97. So everybody has this in your book. I know you can go find it. So 24 square units. I'm going to jot that down. The area is 24. So kids, what we're going to do first is just what we did on our example problem. We thought of all the ways to get, what was the number? 12, I guess, and 15. Let's think of all the ways that we can multiply to get 24. Well, there's 1 times 24, 2 times 12. Let's see, we could do 3 times 8 is 24, and we can do 4 times 6. Can we do any others? 7 times, nope, 8, yep, we did the 8. So these are the 4 ways that we can make 24. And if you have a hard time seeing that or knowing that, it just means you need some more practice with your math facts, okay? It just means you got to think of what do I multiply to get 24? And I just systematically started with 1 and then 2 and 3, and I keep going until I have reached the numbers that I already multiplied. Like when I got to number 8, I knew I don't need to keep going because 8 times 3 is 24. So it's the same as 3 times 8. I don't need to keep wondering if I missed any factors because I got them all. Okay. 1 times 24. So we're going to draw this. 1 times 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I can't go all the way across. I have to go up and down. So 1, I'll go this way. 1 times 24. One group of 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, I'll do this in pink so you can see it a little better. So I had one group of 24. So we are building it or drawing it with unit squares. One group of 24. And if it helps you to see it, you could put the dots in there like an array. So this is literally one group of 24. You could put the dots if it helps you remember what you were doing back on this page. On this page when we built the arrays. But you're literally just seeing it on grid paper now. One group of 24. Okay, so we can check that one off. We built that one. Now we need two groups of 12. Okay, I'll just skip a space here. Two groups. Do you care if we go up and down? I don't know if it matters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there's two groups of 12. I guess technically if we were reading this we would say it's more like 12 groups of 2, but it doesn't matter. It has an area of 24. So we did that one. Now we're supposed to do 3 groups of 8. I guess I'll go the right direction for this one. 3 groups. 1, 2, 3, 4, 5, 6, 7, 8. 3 groups of 8. That gives me an area of 24. My 3 groups of 8. And then the last one I'm supposed to draw is 4 groups of 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, I think I better go back and check my directions, make sure we did everything we're supposed to do, or so far. Okay, we built as many rectangles as we could with an area of 24. We did that, so we're done with that part. Shade in the squares on your grid paper to represent each rectangle that you made. Okay, we could shade them in. That represents the area. You could color them neatly. I'm not going to color for time's sake. Now, estimate to draw and label the side lengths of each rectangle you built in problem 1 and find the perimeter of each rectangle. 1 is done for you. Okay, now this is the part. Here's where we built it on this paper. And we know it's exactly 24 units long. But they just drew it here, like just a regular drawing. And they want us to find the perimeter. Well, 24 by 1 by 24 by 1, when we add those up, you get 50. So even though the area was 24 units, the perimeter is 50. Now let's do the next problem. We had a 2 by 12. So I can just draw that out like this. Whoops, that's not very good at all. You guys are so much better at this than me. Okay, 2 by 12. All right, the perimeter is 2 plus 12 plus, it's not labeled here, so I better label it, 2 plus 12. So what's the perimeter of this one? Even though the area was 24, the perimeter of this one is 12 and 12 is 24. 25, 26, 27, 28. 28 units. So the distance around, the boundary around, is 28. Even though the area was 24. There's another one. 3 by 8. 3 by 8. So the perimeter is when we add up the lengths. 3 plus 8 plus 3 plus 8. So that's 11 plus 11. The perimeter is 22 units. And the last one, 4 by 6. 4 by 6 by 4 by 6. So the perimeter is 4 plus 6 plus 4 plus 6. I see tens. So 20 units. Boys and girls, this is what you are doing today. You are making that connection back to area. A long time ago when we filled the space, we tiled in spaces and counted how much space was filled. That's what this was. But today you're exploring how perimeter and area relate. They are never, well, okay, they're not usually the same. So in all of these rectangles, the area was 24, but the perimeter was 28 when it was configured like this. It was 22 when it was designed like this, and it was only 20 when it was designed like this. Area and perimeter. I hope this helps you as you're thinking about area and perimeter, and I want you to take your time so that you really can understand these concepts. They're important for 3rd grade. Have a good day, kids.